Hello everyone. This video is on the Knewton Alta assignment, section 2.4, part 1, called Basics of Complex Numbers. In this video, I'm going to be going over a preview version of this particular Knewton Alta assignment. Please understand that the questions I see in this video may or may not be the exact same questions that you see when you work on the assignment yourself. But the objectives are the same, so the types of questions should be similar. And I'm hoping that watching me go over a few of them here help you in some way when you're doing the assignment on your own. Alright, so here's the assignment page. You will not see the words preview of, you're just going to see the title. Mastery bar up here telling you how far along you've gotten. You can see the objectives. Looks like there are only 2 objectives in this particular assignment. Then under the current objective is a question related to that objective. And at the bottom of every question you should be seeing a feedback button where you can send feedback to Knewton about a particular question you're working on. Maybe you see a typo or some sort of mistake that they could fix. You will not see the instructor cheat button. That's for instructors only. You will see the More Instruction button. It's very useful. If you're ever struggling with a particular objective or a particular question, click on More Instruction and it'll take you to a page with some reading to do or some videos to watch. And then you'll have questions there related to that instruction. And when you do questions correctly there, it will progress you through the assignment. Right, so you could, if you wished, click on More Instruction every time you get a new question. Might take a little longer, but it's still doable. Alright. So before I get into any of this, I want to talk about the complex numbers, the imaginary numbers. Alright. So before I get into this question here, I'm going to talk about sets of numbers real quick. Some important sets of numbers that most of them you've probably heard of. Sorry, I forgot the N there. Sets of numbers. Alright, so usually people start off with the whole numbers or the counting numbers, the natural numbers. I'm just going to start off with the integers. You've probably heard this word before, integer. The integers is simply this set. So you got braces and it's like dot, 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 ellipses, going that way forever. -4, -3, -2, -1, 0, 1, 2, 3, and so on. Right? You just keep adding 1, subtracting 1, and you get all the integers. So another way to say this is it's all the whole numbers and their opposites. Alright, then the integers are a subset of what's called the rational numbers. Alright, now the rational numbers I'm not going to list like the integers. The rational numbers I'll write in set builder notation. Every rational number can take this form: m divided by n, such that m and n are integers. And of course, since we have n in a denominator, that can't be 0. Alright, so these are all your fractions. Now, like I said, all the integers are the integers are a subset of the rationals. So, all integers are rational. Because you can always put any of these over 1. 5 over 1, 7 over 1, right? -8 over 1, right? And write them in this form of m over n, where m and n are integers. And then your fractions, right? Your ratios of integers, thus the name rational, right? 2/3, 2 over 3, -5 over 7, 2 over -85, whatever. Right. Okay. All right, then you have a totally separate set. Right, the integers and all the integers are rational, and then we have a totally separate set called the irrational numbers. And these are real numbers that are not rational. All right, so we'll get to the real numbers in a second. All right, but these are basically just real numbers. I don't know why I put the set brackets there, but a set of real numbers that are not rational. So if they're not rational, what does that mean? That means they can't be expressed as a ratio of two integers. I can't write it as 2 over 3 or 5 over 9 or whatever. So some examples of irrational numbers, pi, probably heard of pi before. 3.14159, blah, 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 right? It just goes on forever without ending, without repeating. And that's the thing about irrational numbers, is if you write them in decimal form, their decimals never end and they never repeat. Right? Parts of them may repeat, but there's never a sequence of digits that repeats forever. Right? Pi, the square root of 2, the square root of 3, all your roots of non-powers, the square roots of not perfect squares, square root of 5, right? The square root of 4 is 2. That's rational, right? That'd be an integer. But all the square roots of non-perfect squares, cube roots of non-perfect cubes, and so on. You may have heard of the number e before. That's like 2.71828, right? Again, for all these irrational numbers, the decimal doesn't end, and it doesn't have an infinitely repeating sequence. All right, so I mentioned the real numbers, and real numbers have been brought up in previous videos. You've heard real numbers be brought up, I'm sure. All right, what are the real numbers? Well, the real numbers are just the rational numbers in union with the irrational numbers. So basically, every number that can be written as a ratio of two integers is called real, and every number that's not rational on the number line is called real as well. Right, and again, this is usually represented by a number line, right? And you've seen number lines before, I am certain, right? 0 in the middle, positive reals to the right, negative reals to the left. Okay. Now, the thing about real numbers is that when you square them, you always end up with a non-negative result. Right? The square of a real number the square of a real number is always non-negative. Right? For example, take any positive number, like 3, and square it. 3 times 3 is, 9, non-negative. 0 squared is just 0. That's non-negative. Take any negative number, right? Negative number on the line, negative 1/4, and square it. That's, positive 1/16. Remember, a negative times a negative is a positive. Non-negative. So if you take any number on the real number line, any real number at all, and square it, the result is non-negative. But there are scenarios, where we might have to solve an equation or see something like this. But what about x squared equals -1? Huh? How about equations like that? What would we do in this situation? There are no real numbers that you can. There are no numbers on the real number line that you can square to get -1. So, a new set of numbers is developed, or discovered if you want to talk about philosophy. So we're going to go into a whole new set of numbers now. And this is where we're going to get now into what this section 2.4 part 1 assignment is about. We have a totally separate, so you have the reals, and then you have a totally separate set of numbers called the imaginary numbers. Now don't let the name fool you. They aren't imaginary. They exist. I mean, just as soon as I write it, it's there. All right. I think a mathematician named Carl Gauss from Germany, way back when, named these. Obviously in German, not real and imaginary, but the translation to real and imaginary. I don't like the names particularly because it confuses people. I feel like people are confused nowadays. They think imaginary, oh, they don't exist. No, they exist. They're there. All right. Imaginary numbers. And now this isn't a perfect definition, but it's the way I like to think about them. These are numbers whose squares are negative. Numbers whose squares are negative. And the most basic imaginary number is called the imaginary unit. And this is given the symbol I, a lowercase I, for imaginary unit. And I is defined to be the square root, the principal square root of -1, because remember, every number has 2 square roots, a principal square root and its opposite. I is called the principal square root of -1. What this means is that if you square I, take I to the second power, the result is a negative number, namely -1. All right, so you're going to have to remember this stuff here especially. All right, this I being the principal square root of -1. So when you see I squared, that's -1. That's going to be key for the rest of this video. All right, so what are some other numbers that are imaginary? All right. Well, every imaginary number, so again, the imaginary numbers I'll write out one more time, looks like the following. Right, so the imaginary numbers are this set. Every single number in this set can take on the following form: b times I, where b is a real number. And I is this imaginary unit, right? So for example, Obviously, I is imaginary, right? It's 1 times I, but you could do any real number. 2 times I is imaginary. 3 times I, -5 times I, whatever, right? These are all imaginary. Pi times I, square root of 2 times I, right? And so on. Take any real number you wish, any number from the real number line, and multiply it by this I, and it becomes imaginary. Now watch. Remember I said earlier, these imaginary numbers are the numbers whose squares are negative. Let's see what happens when I take 2i and square it. Now this is the same thing as anything else. This is 2i times 2i, and you can almost treat I like a variable, like x or something. This would be 4 times I squared. But remember, when you see I squared, that's -1. So this ends up being -4. So when you square 2i, it's -4. That means that the square root, the principal, because it's a positive, not a negative sign in front, the principal square root of -4 is 2i. Same thing for 3i, If I take 3i and square it, this is 9i squared, but I squared is -1, so this ends up being -9. So the principal square root of -9 is 3i. Right. And in fact, what I've got going on over here is something you're going to need to know. This is actually one of the objectives from this section. Right. It's how to rewrite the square root of a negative number using the imaginary unit I. So in fact, in general, we're going to rewrite the following. If n is positive, then the square root of -n, right, the opposite of a positive number would be a negative. Remember this, we've said this many times in previous videos, the square root of a negative number is not real, right? It's one of these imaginary folks, right? How we're going to rewrite it is as the square root of n, right, a real number, times I. All right, please do this. Please know this. Always do this. Whenever you see the square root of a negative number, rewrite it this way. It will help you immensely in the long run if you immediately do that. I promise you. So some examples, and we'll get to more in the exercises in the video as well. Right? The square root of -1, we already saw, was I, 1 times I. The square root of -2 is going to be the square root of 2 times I. Now make sure the I is not inside the square root. In fact, sometimes people often put it in front of the square root, so square root of 2 times I, or I times the square root of 2, same thing. And this is the number that if you were to square this number, you'd get -2, right? This is the principal square root of -2. Square root of -3, you can write as this, you're going to rewrite as the square root of 3 times I, or I times the square root of 3, same thing. And when you square this number, it would result in -3. We already saw the square root of -4, right? That's the square root of 4 times I, but the square root of 4 times, I, that's 2 times I, which we already saw, right? And so on, right? But just please, 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 I'll even put little highlight marks, make it look like a sun or something, all right? Just whenever you see the square root of a negative number, rewrite it this way, please. Right? Do it immediately. It'll just make things that much easier in the long run. All right, so that actually takes care of one objective. We'll see later. The other objective is on powers of I. So I want to talk about that now too. And then finally, get back into the question that we're being asked in the assignment. All right, so now powers of I. Now we know, I to the first power is simply I, right? Anything to the first power is itself. And we've seen, hopefully you've seen this before too. Any non-zero number, and I is not zero, okay? Any non-zero number to the 0 power is 1. Oh, and you know what? I forgot to talk about the complex numbers. The complex numbers are just, you take a real number plus an imaginary number. That makes a complex number. So every real number is complex, every imaginary number is complex, and any sum of them is complex. So we'll talk more about complex numbers in general anyway in a future video. Anyway, back to powers of I. Sorry for the tangent. So I to the 0 is 1, I to the first is I. We saw on the previous page, I squared, right? I is that square root of negative 1. So I squared is negative 1. All right, now we get to some higher powers. Now what about I cubed? Now I cubed, I to the third power. Now this is, you're going to have to take advantage of some properties of exponents. This is I squared times I to the first, isn't it? But what was I squared? That was negative 1. So this is negative 1 times I, or just negative I. And look at these outputs here. Look at all these. I to the 0 is 1. I to the first is I to the second is negative 1. I to the third is negative I. And what you're going to notice when I start getting the higher powers is that these 4 results, 1, I, negative 1, negative I, will keep repeating in a cycle of 4. These are just going to keep repeating. I'll put them in a nice little box here. Hopefully that's not too faint. So watch, let's see that. Right? How about I to the fourth? Now I to the fourth, you can think of a couple ways. That's I squared, right? Power to a power rule. Multiply the powers. And what was I squared again? I squared was negative 1. And what is negative 1 squared? That's positive 1. Hey, right? So I to the fourth is positive 1. And look at this. So was I to the 0. I to the 0 was 1. I to the fourth was 1. All right, and what you're going to see is that that's going to keep happening. Every 4 powers, the result will be 1. So, like I said, I to the 0 will be the same thing as I to the fourth. And that'll be the same as I to the 8th. And that'll be the same as I to the 12th. Just keep adding 4. I could also subtract 4. We could get negative powers in here. I to the negative 4. I to the negative 8. And so on. And so on. And all of these will be equal to 1. They'll all be equal to 1. So if your power is a multiple of 4 on I, your power of I is a multiple of 4, the result is 1. It simplifies to 1. And I'll come back to that page. All right, let's keep going. How about I to the 5th? So I to the 5th, we can think of this using some exponents here, properties of exponents. This is I to the 4th times I to the 1st. And what was I to the 4th? That was 1. And 1 times I is just I. And oh, look at that again. See how it's repeating this cycle? I to the 1st was I add 4 to the power, and it's I again when it simplifies. And that will keep happening. So we have, I to the 1st will be the same value as I to the 5th. And this will be the same as I to the 9th. And I to the 13th. And so on. We just keep adding 4. And same thing the other way. I can keep subtracting 4 from the power. 1 minus 4 is negative 3. I to the negative 3. I to the negative 7. And so on. All of these powers of I will simplify to just I to the first. And the thing about all these is that they're some multiple of 4 plus 1, right? This is 4 plus 1, 8 plus 1, 12 plus 1. Every single one of these powers is a multiple of 4 plus 1. All right, then how about the next one? I to the 6th. So here, I to the 6th. And I can think of this as I to the 4th times I to the 2nd. Well, I to the 4th was 1. Right, we saw that. I to the 2nd is negative 1, and 1 times negative 1 is negative 1. And look, it's the same 3 repeating. 1 I negative 1. 1 I negative 1. Right? And look, I squared was negative 1. Add 4 to the power, I get the same result. I to the 6th is also negative 1. Right? And I can keep doing that. Right, so back to this page. So I squared has the same value as I to the 6th, as I to the 10th, as I to the 14th, and so on. And again, you can also subtract 4, go into negative powers. So I to the 2nd will be the same value as I to the negative 2nd, I to the negative 6th, and so on. These will all be equal to negative 1. They will all simplify to negative 1. And the thing about all these powers is that these are all some multiple of 4 plus 2, right? 10 is 8 plus 2, 6 is 4 plus 2, 12 plus 2 for 14, right? They're all some multiple of 4 plus 2. Right? And then I to the 7th, again, we can think of I to the 7th as I to the 4th times I to the 3rd. Now I to the 4th we've already seen is 1. I to the 3rd we've already seen is negative I, and 1 times anything is itself. So this ends up being negative I again when you simplify it. And look, the cycle repeated. 1 I, negative 1, negative I, 1 I, negative 1, negative I, negative I, right? And, you know, I to the 3rd was negative I. Add 4 to the power. I to the 7th is also negative I, and I can keep doing that. All right, so this will complete this page. So I to the 3rd, right, has the same value as I to the 7th, I to the 11th, I to the 15th, and so on. And subtracting 4, I get I to the negative 1st, I to the negative 5th, and so on. All of these have a value equivalent to negative I. All right, I'm going to put this in a box here. All right. And the nice thing about all these powers is that they're some multiple of 4 plus 3, right? 8 plus 3 is 11, 12 plus 3 is 15, 4 plus 3 is 7. So the key here is taking your power and finding the remainder. Take the power on the I, the exponent, find the remainder when you divide it by 4. Right, when dividing by 4, right, this repeats every cycle of 4. And that remainder is going to be either 0, 1, 2, or 3. If the remainder is 0, then it's just going to simplify to 1. If the remainder is 1, the power of I will simplify to I. If the remainder is 2, the power of I will simplify to negative 1. And if the remainder is 3, the power of I will simplify to negative I. All right. So this is huge here too. How are you going to simplify these powers of I? Okay. So finally, we get back into the problems. All right. So, question 1 is on this objective, simplify powers of I. So, simplify, and again, notice they give you the same, the four choices: 1i, -1, -i, right? So it's going to be one of those four every single time. What's I to the 83rd? All right, so I'm going to write that out. So I to the 83rd power. Now again, you're going to take 83, and think of how many times 4 goes into it. Right, 83 is 4 times 20, right? That's 80 plus 3. So the remainder is 3. And you can just do the shortcut I wrote up earlier. If you know the remainder is 3, then it's going to simplify to -I. Right, but let's go through this. Right, so this is I to the 4 times 20 plus 3, right? That's the same thing as 83. And then using some properties of exponents, right? This is equal to I to the 4 times 20 times I to the third, right? Because remember, when you multiply things, you add the powers. There's addition there. And then this I to the 4 times 20 is I to the 4th to the 20th, right? Power to a power, you multiply them, times I to the third. And I to the 4th to the 20th, that's just 1 to the 20th. That's 1. And we saw I to the third was -I earlier, right? That's I squared times I, -1 times I. So this ends up being, I to the 83rd equals -I. Right, and I wrote this up earlier. This is a nice, I'll be using this shortcut from here on out, though. We divide by 4, and if it's a multiple of 4, you're going to get 1. If the remainder is 1, you get I. If the remainder is 2, you get -1. If the remainder is 3, you get -I. Right. So back on the assignment, I to the 83rd simplifies to -I. Submit. And again, after every question, there's answer explanations. It would be beneficial to read through those just to make sure you understand why you got something right, or definitely why you got something wrong. All right, so moving on. All right, so now, like I mentioned earlier, the expressing the square root of a negative number is a multiple of I, right? How do I write the square root of -9 in terms of I? So going back to my paper. All right, and again, I keep this going, square root of -9. All right, I'm going to rewrite as the square root of 9, a real number, times this I. And the principal square root of 9 was 3, right? So I'm just going to be rewriting this as 3 times I. 3 times I. So down here, 3I. Very, very simple. Submit. Come on. All right. Okay. Moving on. All right, so another one of these where it's the square root of -99. So same page. Square root of -99, I'm going to rewrite as the square root of 99 times I. And again, make sure the I is not in the square root. Now the square root of 99, you can simplify, right? They want you to simplify these. It's the square root of 9 times the square root of 11. So this will be 3 times the square root of 11, right? That's still a real number, times I, and there's your imaginary. And this is what they want us to enter, right? With the simplified square root in simplest form, they said. So we have 3 times the square root of 11, and then get out of the square root and then put an I after it. Or you can put the I before it, like I told you earlier. Right? Next, and again, these are all pretty simple here. I to the 73rd power. All right, what's I to the 73rd power? So again, back to my powers of I page. I to the 73rd power, 73, you think of how many times this 4 goes into 73. 4 times, 4 goes into 72 18 times, right? 4 times 18 is 72, and then plus 1, and all I care about is the remainder, and the remainder is 1. So this will be equal to I to the first, which is just I, right? I to the first was I. So this I to the 73rd power simplifies to I. Again, read through the answer explanations. Back to this. Now the square root of negative 63. Once again, I'm going to rewrite this. All right, square root of negative 63. I'm going to rewrite this as the square root of positive 63, a real number, times I. And this is 3 times 21, which is 3 times 3 times 7. So this is 3 times the square root of 7 times I. Right, when you totally simplify, square root of 9 times the square root of 7. Right, and they want it in that simplest form. Right. So 3 times the square root of 7, and then get out of the square root, right? Make sure the I is not in the square root, and then times I. Right? So yeah, after that whole big initial discussion, right, we're kind of flying through these. Alright, so one more of these. Now square root of negative 18, this time I won't even write it out. It's the square root of 18 times I, and the square root of 18 can be rewritten as the square root of 9 times the square root of 2, which is 3 times the square root of 2, and then get out of there, times I. Right. Great. Alright, so that objective's done. Now the only other problems left are these powers of I then. So what's I to the 70th power? Simplified. So I to the 70th power. You know, again, just basically which of these lists would it be on? Which of these 4 rows? Well, 70 is 4 times now. 4 goes into 68 17 times, right? 4 times 17 is 68, and then plus 2, right? So this is equal to I squared then, which is negative 1, right? Yeah, I to whatever power will be equal to I to the remainder when you divide by 4. Right? And as I said, when the remainder is 2, that simplifies to negative 1, right? I squared is negative 1. So this one, I have to type it in. Right? I to the 70th is negative 1. Right. Moving on. All right, just one more of these. And what's I to the 57th? All right, so once again, what's I to the 57th power? Now 57, when I divide by 4, 4 goes into 57 14 times. 4 times 14 is 56, actually, right? So I need one more, right? And that's the final result. I to the 57th would be equal to I to the 1st, which is just I, right? When the remainder is 1, the result is I. Right? So just I, not EI. Why do I have E there? Just I. I to the 57th is I. Great. And again, just pay attention to the remainder of the power when you divide by 4. And it's going to be 0, 1, 2, or 3. Right? If you're doing things right. And that should tell you what the expression is going to simplify to, these powers of I. And also, too, you got those square roots of negatives, right? Those square roots of negative numbers should be easy to rewrite with that imaginary unit I. Just write the square root of the positive number times I. And of course, they want you to simplify the square root of the positive number if you can. All right, and that's it. That should be it for this preview of this assignment. Now, as I said at the top of the video, right, please know that the questions I saw here may not be the questions that you see when you work on the assignment, but the objectives are the same, those 2 objectives, so the questions should be very similar, and the way you work on them should be similar, the same way I worked on them. So I'm hoping that watching me do it here helps you when you're working on it on your own. And thank you very much for watching.